That brings us to the final presentation of the day, and as we know, this is the graveyard shift, and so we have to save our most exciting speaker for last. So for the next session, we are diving into the next frontier of genetic selection, which is breeding for healthier calves. A dairy farmer herself, Michelle Axford has spent her career making genetic selection more accessible and useful for farmers and their advisor. As a leader at DataGene and a PhD candidate at La Trobe University, she's been working with 50 farms and 20,000 calves to see if genomic breeding values can improve calf health and survival rates. This is cutting-edge research with real-world impact, so let's welcome Michelle Axford with genomic selection for healthy calves.
What if there was something that we could do? What if there was something that we could do to reduce the stillbirth rate for Holstein and Jersey calves and other breeds? If I think back over the past 40 years, the people in this room and the researchers and the farmers and industry, they've worked together to make extraordinary improvements when it comes to improving the productivity of cows. But our calves have been forgotten. This is why I was so interested in seeing, can we use genomics to improve the fate of calves? I was interested in traits like stillbirth, pre-weaning mortality, scours, respiratory disease, and even pestivirus. But they said at the start, Michelle, it's a pipe dream. We don't have the data to be able to work with these calves. But we've got something special up our sleeve. With the help of over 50 herds, thanks to Trevor and Anthea, and Tim and Sarah, Brian's here, Con and Michelle, and lots of others, we were able to amass a data set that did give us the opportunity to explore improvements in calf health. Thanks to the support of Agriculture Victoria, the Gardner Foundation, Dairy Australia, Dairy Bio, DataGene, and Zoetis. Oh, and of course, La Trobe University, which helps me do this PhD. So from those 50 herds, they're herds just like any others that you're working on, you know. They've got issues with a few stillbirths, 6% of the calves had scours, 2% of them sort of died before weaning, about 4% of them were dead at birth. But together with this information, we were able to amass a data set of over 20,000 calves with their DNA information, their family tree, and their health records. So this gave us an opportunity to look into these traits. So let's take them one by one to see what the results were. Let's take the case of stillbirth. Now, stillbirth is an interesting trait because it takes two to make a tango. In this case, we're interested in, can the calf be born alive? And we're also interested in, can the cow deliver a live calf? So there are two parts, stillbirth direct and stillbirth maternal. Let's go the other way. I forgot to mention one thing about these 20,000 calves. One thing that also happened when we were talking with these 50 farmers about the calf health issues is they said, but we don't just want to tell you, Michelle, about the health events. We want to tell you about those calves that really cause us problems when it's late at night and we just want to get home and the calf won't drink. So we introduced a new trait called calf vitality. It's a farmer-scored trait where calves are scored between A, being a ripper, and D, being a dud. And this takes into account the fact that farmers just know calves. They know a good calf. They know the calves that are time wasters and those ones that are fantastic. And so calf vitality is a trait that builds on the work that we've done with workability traits over a long period of time and uses the same sort of thinking to apply to the issue of improving calf health. Now the question is, what did we learn? So in the case of stillbirth, as I mentioned, we've got the stillbirth direct and stillbirth maternal. 2% of the differences between animals can be explained by genetics. Now, the geneticists in the room are probably getting really excited at this point because this is similar to the traits, like other health traits, that are complicated to work with. And so being able to measure 2% of the variation and assigning that to genetics is actually kind of a cool result. For the rest in the room, you're thinking, well, 2%, that doesn't sound very much like fun. But it is similar to traits like fertility that we've made extraordinary improvements to by being focused on improving that particular trait. What else did we learn? Well, in the case of scours, 4% of the differences in calves on the trait of scours could be explained by genetics. Pre-weaning mortality, a little bit lower at 1%. Calf vitality, that trait that sounds like a pipe dream, farmers just scoring rippers and duds, that doesn't kind of maybe sound very scientific sometimes, but we were able to explain 11% of the differences in calf vitality through genetics. As in research, not everything works. In the case of respiratory disease, I couldn't get the models to work very well there. It was virtually impossible to measure genetic variation in respiratory disease. Now, that's unusual compared to other countries that have been more successful, but we just didn't have very many cases of respiratory disease in this data set. Less than 0.5% of the calves had a recorded case of respiratory disease. The same is true for pestivirus. Again, very low incidence of this disease, and it meant that we weren't able to measure genetic variation. So, how on earth did we get to these results? Well, geneticists have this extraordinary tool at their disposal. These are some mathematical models that help us make sense of really complex biological data by looking at the trait of interest and first accounting for the things that we know already influence calf health. So in our case, things like, the management of the herds and the calving ease experience when the cows calve, these things play an important part as to whether the calf is born dead or alive and whether it's healthy through to weaning. The age of the dam is another example. Now, some of these things we can do some things about on farm, and we already do things to help to improve calf health, like housing and making sure they've got great colostrum and looking after that cow that's close up, making sure that she's ready to go. So these are all really positive things that contribute most of the differences to the success of calves. But there is a small genetic component that we've got the opportunity to leverage. You might be asking, 2% doesn't sound like much, Michelle. Does it make a difference? So if we take the case of stillbirth direct, and we separate the best bulls from the worst bulls from this research, we counted 8 more live calves per 100 by using the best bulls versus the worst. 8 more live calves per 100. I'll let the farmers in the room decide if that's a meaningful number to them. In the case of stillbirth maternal, so this is a cow's ability to give birth to a live calf, about 5 more live calves per 100. So I think these results are pretty promising to suggest 2 things. One, we have an opportunity to improve calf health using genomic selection. 2, for our generation and for the next, there's great value in improving records, especially keeping those calving records that are so important to calves' health. Look forward to sharing more about this story with you over a beer later on, because I know that's coming up. And thank you for your attention.
Wow, thank you so much, Michelle. That was amazing. I actually wasn't prepared for you to finish, so that's great. I'm giving you this bottle of... No, I'm kidding. I'll give you that later. Hang on, just wait. So thank you for your presentation, Michelle. That was really fascinating, and your introduction gave me some chills, like genuine chills, so nice work on that. I'm wondering, does anyone in the audience or online have some difficult or not so difficult questions for Michelle Axford at this point in time? Oh, yes, one over there.
Great presentation, Michelle. When it comes to the respiratory stuff, if you were using some of the techniques like the US have got in thoracic ultrasound, would you been able to get a bit better data and stuff like that?
Yeah, that's certainly possible. This is the start of, a journey that could be quite rewarding in terms of the use of sensors and other automation tools. In the case of scanning lungs, makes a lot of sense. I've been speaking with vets in Australia that have had a go at that. So far, the numbers aren't really at a scale that we could use from a genetics perspective, but let's see where that goes down the track. But in addition, you could imagine how automated calf feeders with milk intakes, feeding behavior, scores, other signals of health issues, those all could also contribute to breeding values that could improve calf health. It's just the start of the journey.
Great question. We'll go to that lady next, and then you, Louise.
Hi, Michelle. It's Claire Hill.
Could you stand up, please?
Oh, can I stand up? Of course.
Thank you.
Hi, Michelle. It's Claire Hill from Dairy Bio. We know each other quite well. Thank you so much for your presentation. It was really interesting and very stark with the black and white slides. I like that. Is there a difference, or can you say with 8 live calves per 100 more, 5 live, now my notes are rubbish, so 5 per 100 something else, which I haven't written. Was that the same for Holstein and Jersey? Do you have the breed distinctions there? Just curious.
Yes, certainly. And it's reported in the Journal of Dairy Science, that paper that came out earlier this year. And actually, the standard deviation's a little bit higher even in Jersey. So I've just reported the Holstein numbers for simplicity up here, but people can have a look at that Journal of Dairy Science paper if they'd like to have a closer look at Holstein versus Jersey. There's promise for both.
Thank you. Great question. Louise.
Hi, Michelle. Louise Sunderman again. So you were saying that it takes 2 to tango, and you were sort of highlighted the maternal impact and then the calf impact. But something that has been talked about a bit more recently is the role of the father's health and general genes on the pregnancy quality in humans, so placental health, etc. How much, have you explored, or is it an area that you have been looking at, the role of sire and the sire health and the epigenetics around that?
Yeah, that sounds like a fascinating area. But, that's not something I was able to explore with this PhD. These are ongoing journeys, and so you never know where that leads, but that's not something I had the opportunity to look at with this project. Sorry, Louise.
Thank you, Louise. I think we have another question at the back.
Hi, Michelle. I'm just really keen to
Sorry,
know...
just to interrupt. Just your name and where you're from.
My name's Anthea.
This is Anthea.
And I ran around and collected TSU samples for Michelle from dead, dying and very much alive calves. I'm really keen to know when we might be able to get these results that we'll actually have to use on farm so we can select bulls on calf vitality.
Thanks, Anthea. Look, one of the lovely things about the way that our industry is constructed is that we've got research working hand in hand with the partners at DataGene that can implement. And, already while the research was going through, I've been communicating that back to my colleagues at DataGene. And it's part of the current annual operating plan to develop the backroom work that has to be done before a trait's implemented. I'm not going to commit DataGene to a timeline because that's for them, but if we think over the next sort of year or a bit more, we would likely see some breeding values from this research implemented. One of the things that Tim mentioned earlier was the Genetic Evaluation Standing Committee, and there's a whole process to make sure that, while the ideas might sound good on paper and research, what makes sense to actually implement. And through the advice of the Genetic Evaluation Standing Committee, they'll get involved in helping to make decisions about where this heads. I think to help them, some research that we did through gathering survey feedback from over 100 people about how these traits should be, named, the sort of direction of the breeding, whether you bundle them all up together, whether you look at them sort of separately, the value of calf health in comparison to other traits. That's been pulled together as well as a supporting document that helps to make some of those decisions about where it goes next.
Great answer, Michelle. Do we have any other questions from the floor? I totally have one, Michelle. So I'm looking at your stillbirth models, and I'm wondering, in light of the earlier presentation about the increase in the frequency of lethal haplotypes, I'm wondering, could some of those stillbirths be explained through that mechanism, or is it still too sort of early in our script to tell?
Well, actually, as we speak. Soon there's a paper that will likely publish that reports about 200 significant variants that influence calf health, and another almost 200 haplotypes that are deleterious when they're found kind of as in the homozygous state. So there certainly is a lot of action happening there along the genome that we don't completely understand yet. But the keys to kind of translating this from where we are now to where we are in the future is by continuing to have some data to be able to kind of work with partners overseas that are also working in this area to see how we might be able to incorporate that information into SNP chips that we use to genotype our calves down the track. There's certainly a lot of busy activity, but not something that's concrete that farmers can use today to make better decisions over and above a breeding value.
Okay. Thank you so much, Michelle. I know that your research always has that implementation, that practical focus at the end of it, so that's something I really appreciate about your work, so thank you very much. Okay, everyone, thank you very much, and please take this bottle of wine.
We'll share this later.
Oh, no problems.